Okay guys, so we're going to draw up this half-inch drive adapter. I'll leave a link in the description box for the print dimensions for this Google Doc right here. But anyways, so this is the isometric view. This part right here, one side has a hex with a 1/4 inch pocket. Notice that the corners of the pocket have radiuses for clearance for the end mill. This is the side view. So one side's hex, the other side tapers up to a round diameter of 1.37. So what I'm going to do is I'm going to draw a round part and go ahead and put the taper. Usually I don't put the chamfers on it, but this part's a little tricky. So what I'm going to do is I'm going to go ahead and draw it up around, put the taper on there, and so when I cut the hex, it cuts up to that face, right? Let's see, which side view. So it cuts up to this face right here, and we don't have any excess material to say. Okay, so there's 1.1 dimension. I really can't go off that. Basically, I'm going to draw a 6-side polygon, which is a hexagon. Flat to flat is going to be 0.99. Okay. Now, Fusion 360, you have to enter from flat to the center of the polygon. All right, so it'd be 0.99 divided by 2. All right. So the overall length is 1 inch. The largest diameter is 1.37 with a 0.99 hex, right? So what I'm going to do here is I'm going to draw up a part, and there's a couple ways to do this. Go ahead and create a new sketch. I'll go ahead and select the top view, and we'll draw a circle. And remember, use the keyboard shortcut C for circle. Okay, so this was a 1.37 inch circle. That's basically, we'll go ahead and put it at 512 thousandths long. It's not really 512, but we're gonna add the chamfer. So I'm gonna extrude this up, and you can draw the cross section too. That's a more formal way of handling cylindrical parts. So 512 thousandths. And this is in inches, by the way. Alright, so I'm going to go ahead and add onto that circle. So I selected a sketch plane on the face of that. So that's going to be the shoulder. The shoulder is 512. And basically we're going to draw... Well, what we could do, we could go ahead and draw the hex. You know, I'm gonna hit back. I think I'm gonna do this a little bit different. This part's a little tricky. It doesn't look tricky, but it is. So I'm gonna go ahead and add that chamfer. Now the chamfer, is 0.13 to 0.14. So we'll say 0.13. So I'm going to select this right here and make it 130 thousandths chamfer. So it looks like that. And I'm gonna go ahead and create a sketch plane right here. And we're gonna draw a polygon. So it's gonna be a circumscribed polygon. So the math is gonna be based off the flat. Okay, so from flat to flat it's supposed to be 0.99. Now notice Fusion's going to give me the distance from flat to the center of the polygon. Alright, so what I'm going to do is I'm going to type in 0.99 divided by 2. And it looks like that. Okay, so the hex is 488 thousandths wide. So I'm going to extrude this up 0.488. So I have something that looks like this. Go ahead and save that. Okay, so we have a 3/8 drive. Basically, this is made for a drive socket wrench to fit in here. With a 3/8 drive, right? So, well, it says 0.37. That's because the drives. This is a considerable amount of weight when it's made out of metal, and you don't want it to fall off the drive. So the drives aren't really 0.375, they're the other size, So this is gonna be 0.37, and it's gonna be on both sides. Now, because it's on both sides, what I'm gonna do is I'm gonna draw it up one time on one side and cut it all the way through, and draw out the rest afterwards. Okay, so we'll go ahead and draw up a 0.37 circle. So I'm gonna create a sketch, select this plane, and I'm gonna go to rectangle, except I'm gonna use my center rectangle. I'm going to select my origin right here, 0.37, hit tab, 0.37 on both sides, and I'm going to hit enter to place it. And we have 4 holes that are 0.13 diameter on a 288 thousandths bolt circle. Alright, so what I'm going to do is I'm going to draw up one hole and position it and dimension it, and I'm going to use my circular rotation tool and circular pattern, and do a circular pattern, and basically create the other 3 based off the first one. So 130 thousandths diameter, 288 bolt circle. So I'm gonna hit C on my keyboard for circle. I'm gonna zoom in, and I'm just gonna place it up here. Alright, the reason why I'm placing it up here is because I don't want to constrain it. I don't want to snap on to one of these lines, right? Or this corner. Because then the circle would be constrained and I couldn't move the position in the circle. Alright, so it's a 0.13 circle, and it's on a 288 thousandths bolt circle. So basically what I'm going to do is I'm going to hit D for dimension. I'm going to select my circle here, and I'm going to select the origin, and I'm going to place that leader line. So it's 288 thousandths bolt circles. So I'm going to go 0.288 divided by 2, because I'm dimensioning from the origin there. So I got my vertical dimension. So now I'm going to add a horizontal dimension. 0.288 divided by 2. I'm going to go ahead and trim this up before I rotate it, because it'll save me some work. Alright. So now I'm going to go to create, circular pattern. I'm going to select this arc as my object. My center point is going to be the origin right here. And as you can see, it's got a preview of 3 more arcs, 120 degrees apart. So I'm going to bump this up to 4. And the preview looks good, so I'm going to hit enter. Now I'm going to go ahead and trim up these corners here. And you don't actually have to do that. I just like to clean it up. Okay, so there's a light right here. This the rectangle is actually 0.378. Okay, now that's an easy fix. You kind of know how to do this anyway. Say if you draw it up wrong, right? So what you could do, let's see. Okay, so what we'll do is we'll just go right here, dimension from here to here, 0.378. Now dimension from here to the origin or center. Okay, so it's gonna overstrain it if I do it right there. Let's try this in. Alright, so why? Okay, I'm gonna show you a better way to do it. That didn't work out. Alright, this is what we're gonna do. Alright, so I'm just gonna place another rectangle. So stuff like this happens all the time. You draw something up, and you look at the print again, and you're like, oh, I need to fix it. So here's a quick, easy fix. So I'm gonna draw a box over it, 0.378. Tab 0.378, hit enter. Now if I zoom in, you can see I have extra geometry here. So I'm going to go to trim, and I'm going to trim up what I don't need. Easy fix. This isn't just a lesson in how to draw this part, this is a lesson in just how you use Fusion 360. Go ahead and finish trimming up what I don't need. Alright, go ahead and save. Okay, so there's a through hole through this. And the through hole, I wonder if we should draw this through hole up. I'm trying to take the most efficient way. I'm gonna go ahead and just draw a circle up. So there's a through hole. It goes all the way through. Obviously, that's why it's called a through hole. Okay, so, so what I'm looking at is, if I extrude this, this is what I get. It still has this material right here. And if I go to my bodies list, I actually have 2 bodies. This 0.37, what was supposed to be a through hole, is now another body inside, right? So I'm just going to delete that. Alright, so see how it deletes the whole cylinder? So what we're going to do, I hit undo a couple times, and we're not going to be able to use that. Okay, so I have this all the way through, right? Now, it's not really quite right, because if you look in the middle, if you look at the print, you know, there's a floor in there. So this this drive is 0.378 and 0.378 deep. Okay, I don't think it says it on this dimensions, but I'll update that. And don't ask why it says half-inch drive when it say 0.37 adapter. This originally was a half-inch drive. Let's see, where'd it go? So right here it says leader line. It was originally a half-inch drive adapter to 3/8, but I decided to make this assignment or this exercise a little bit simpler. We'll just do a 3/8 all the way through. So a 3/8 drive is going to be 3/8 deep, okay? So with that said, what I'm going to do, alright, so what I'm going to do here is I'm going to construct a offset plane. Okay, now you don't have to do this. You can. There's other ways of doing this. Well, okay, so notice this. Let's look at these print dimensions. That says 3/8 deep. So right here, according to this dimension, is 0.379. That's where that shoulder is. We'll just go off that for now. So one thing I could do, if I wanted to, I could either create an offset plane. I could also create a sketch on this plane, and then go to my offset. So let me do it. Okay, it's not going to do it. Alright, so what I'm going to do, I'm just going to draw a rectangle. I'm just going to fill in that middle part, basically. See, if you see what I'm doing, that rectangle is on this face, right? So I'm going to hit extrude. I'm going to extrude this rectangle, and we're going to put it on join. And I'm going to extrude this up to this face. Now notice it says minus 512. That was the distance to the face, right? I'm going to go to that face, but I'm going to go plus 0.375. Alright, so if you look at side view, Here, let's do it the other way. So if I join it, I can join it up, because what I'm looking at, it's 0.379 from here, so I actually need to go, I need to add material to the right, okay? So if I need to add material to the right, I'm going to pull this, and that's, the operation's still on join, and you can see it added material right there. So I'm going to go to this face, which that distance would be 0.488. I'm going to go minus 0.375. So it's going to look something like this. Okay. Alright, so now we'll go ahead and hit save. And I'm going to create a sketch on that floor and draw a circle right here. So the circle is going to be 0.37. And I'm going to extrude cut that. So it looks something like this. I may or may not remake this video. I don't know. I kind of goofed up a couple times, but it brings up some good points because sometimes you're going to look at a print and you need to go back and modify it, or you need to have a different, take a different approach. So it kind of shows the example of how to look at the problem and assess it, and different options on how to move forward. So I may leave this video up, but we'll see. Okay, so I have that. Now if we look at the print, we have this these islands that come up, okay? Okay, so if you look at the side view, from the top of this raised surface to the bottom of this raised surface is 1.05, 1.054. Now that's a radius. Probably should have added more notes to it, but this is a radius right here, okay? So just keep that in mind. Okay, so we also have this cross on the raised surface is 0.24 wide on both sides, horizontally and vertically, and that sticks up 190 thousandths in total to the face, but there's this 90 thousandths cut out where the 1.054 diameter circle cuts. So all I'm going to do is I'm going to go ahead and raise it up this dimension right here to 0.19. So I'm going to do, I'm going to create a sketch. Also note the orientation of the cross to the referring to the orientation of the square. All right, you want to keep that in the right orientation. So I'm going to use my center rectangle again. We'll make it 0.24. Now notice I didn't get a vertical dimension. It doesn't matter because I'm going to use this as a tool, and basically this intersection right here will give me a face to select. So I'm going to go back to rectangle, center rectangle. I'm going to select the origin, and I'm going to do a horizontal box, 0.24 wide. Okay, so this is what I'm going to do. So I'm going to hit E for extrude. I'm going to extrude this face, this face, this face, and this face. And I'm going to go ahead and extrude it out 0.19. Well, hold up. One thing, we drew up the main body of this at 1 inch, right? So if we extrude it out, we would now be 1 inch 0.19. Alright, so knowing that, let's reassess the situation. So instead of extruding it out and making the part long, which we could do that, but I'm going to show you a better way. I'm going to clear these profiles, and I'm actually going to select let's see, I'm going to select these, and we're going to cut these in minus 0.19. So it looks like that. And if we measure the overall length of the part from here to here. We have 1 inch. I don't know how well y'all can see it, but it says 1 inch. Alright, so this these legs or raised surfaces, they kind of end up here, right? And if we look at a side view, there's basically a 90 thousandths relief for this 1.054 we'll just call it diameter arc. So what I'm going to do is I'm going to create a sketch plane right here. And I'm going to snap onto this origin. I'm going to go 1.054. Double check that. Yeah, 1 inch, 54 thousandths. And it's 90 thousandths relief. So I'm going to go extrude. I'm going to select this face where it intersects. I'm going to tilt my model to the side a little bit, and I'm going to pull in 90. Okay, so it's, I want to select the whole vein there. What's up with that? Here, let's hit escape and try this again. Okay, so the reason why it's doing this is because I selected this raised surface for my sketch plane, right? Now because that's my sketch plane, these raised surfaces aren't on the sketch plane. So if I try to extrude it, this is what happens. I can extrude this, and I can extrude the circle, but I can't actually extrude this. It wants to extrude the whole raised surface. So what we could do, we'll go ahead and cut this in minus 0.09. So I have something like this. And let's try this. Let's try doing a circular pattern. I'm going to go pattern, circular pattern. I'm going to select this surface. And I'm holding the Alt key down. It's like select 2. And my axis will be right here. And there's 4 of them. So quantity 4. There we go. There's different ways to do this. That's just one way. It's good to explore different ways, different options to draw the same part up, because you're going to run into problems, and it's good to have another tool you can use, or another tool you know how to use. So this is the part, and we'll call this video done. I'll post another video right after this one on how to do the cam. If you actually want to make this, there's 2 lathe operations and 2 mill operations. And I'll post a video. I may get all the operations in one video, or I may have to split it up in 2. We'll see how it goes. But this is it.